Description of parts. Air compressor and governor. The operating maintenance of the air compressor and the governor of the diesel electric locomotive are fully described in the instruction pamphlet number 5002.5-5. The E7A safety valve. The purpose of the safety valve is to prevent the pressure for the predetermined point of the determined hour to prevent the excessive main reserve pressure on the locomotive. When the pressure in the cavity under valve 4 is sufficient to overcome the pressure exerted by the tension of the spring 6, the valve 4 is raised from its seat, which is upward movement to close the upper end of the port D, and the valve bushing opens the port C, permitting the air to flow from the cavity of the pass valve 4 through port C with the atmosphere at pressure below. The valve 4 decreases the tension of the spring 6 force valve or downward, with the restricting open through the port C, the atmosphere, and opens the upper end of the port D for the spring chamber E. Although the chamber E is open with the atmosphere at all times, the connecting parts of the F of the body is sufficiently small, all restricting exhaust such that the pressure builds up very rapidly in chamber E, assists the spring in 6 in forcing the valve 4 to quickly to its seat. To adjust the safety valve with the maximum opening pressure, which should be 10 pounds above the governing cutout point, with remove the cap of the nut 3 screws down and back up the regulating nut 7 and required to replace the cap nut. The minimum enclosing pressure it can be adjusted with the changing of the size of the portion F of the using regulating nut 8 for the purpose of adjusting screw down jam nut 9. The E7B safety valve. The purpose of the safety valve is to prevent the pressure for the predetermined in order to prevent excessive main reserve pressure on the locomotive. The pressure in the cavity under the valve 4 is sufficient to overcome the pressure exerted with the tension of the spring valve 6, and valve 4 is rated from its seat. The air pressure then exerted to the cavity B for the full diameter valve, which provides sufficient extra force to continue the valve moving against the spring 6. Figure 3 shows the E7 safety valve, and Figure 4 shows the E7B safety valve. Air then flows past the valve of the atmosphere through port C, while the opening of the position upper end of the valve closes off the communication with the chamber G with the chamber, so that the air cannot flow through the past port D to the chamber E with air. The pressure valve decreases the tension of the spring 6 valve and forces the valve downward, restricting the open end of the port C with the one stage, and the movement opens the chamber to chamber G and the chamber E. Although the posts are often atmospheric, they may be restricted with the ring of the 8 to allow the pressure to build up rapidly in chamber, assisting spring in the 6 and closing the valve to its seat. The adapter 11 and strainer 10 provide with large capacity pipe connection, replacing the screen from keeping the pipe scale. Other large form articles from the valve seat to adjust the safety valve with the maximum opening pressure, which it can, in this case, fit 150 pounds. Remove the cap nut and screw down and back off the regulating nut 7, which replaces the cap nut. Minimum closing pressure with the safety valve of 145 pounds can adjust with the changing the size of the ports F with the regulating nut 8 for the purpose of after adjusting screw down jam nut 9. The main reserves are used to store and cool the compressed air furnace with the air compressor to collect the water and dirt. The air, each reserve is provided with a drain cock, and means all with the residual may draw off the frequently intervals as the water cooling will soon materially decrease in the air storage capacity. All main reserves are numbered serially before leaving the factory, certifying that certificate that is furnished, setting forth the detail of the design and material construction testing the detachable portion change of the specific information within Interstate Commission. Interstate Commerce Commission now requires all interstate carriers to file enabled reserve recommendation on the amount of the durability protection against the corrosion, oxidation, etc., preserving great factor of safety that does the plain unenameled type. The reserves are enamel and may be special process both inside and out. Figure 5 shows a view of the certified main reserve marking. The Wabco tight union fittings. The illustrated figure 6 shows the main reserve fitted with the Wabco tight flange union. The application of the fitting of the main reserve is extended with the vital pipe connection. Maximum available protection against the pipe at the fitting of the breakage. As shown in the site below, the forged steel flange is set with the welds at the heel head and the reinforced fitting with the copper gasket applied with the 4 cap screws. The welded flange is suitable with a 2-inch flange connection of 1.5 or 1.25 or 1-inch iron pipe is required with the reinforced fittings as available in both straight and elbow types. Figure 6 shows the view of the main reserve with the Wapco type flange union. Figure 7 shows the Wapco type union as applied with the main reserve, the welded copper anchor ring clamping fitting body and forged steel flange. Figure 8 shows the diagram of the M3A feed valve in open position. Delivery and supply, main reserve. M3A feed valve regulates the pressure of the brake pipe with the automatic brake valve in the running of the holding position, and the M3 reduces the main reserve holds for use in the independent brake operation with the train air signal with the M3A and the M3 feed valve identically, except for the M3A is provided with the adjustable stop of the double pressure control. The following description applies equally to the M3A and the M3 feed valve. The diagrammatic views of the figure 8 and 9 picture valve with all ports of the O1 plane in order to facilitate the description. The main reserve pressure connected to both sides of the piston 20, underside of the slide valve with the chamber K and chamber M on the top through the passage N, passage choke at 25 through the passage P through chamber K. Passage N also leads to the top of the regulating valve 7 with the diaphragm chamber under the valve is always communicating with the feed valve pipe pressure through the passage O. The opening. Air pressure enters the feed valve opening of the market is supplied flows to the chamber K slide valve under the piston 20 of the piston spring of the pressure of the feed valve pipe of the pressure combined with the hoe over is less than the main reserve pressure and the slide valve of the chamber under the piston. Consequently, the piston slide valve must move up the position shown in figure 8 with the main reserve will flow to the feed with the valve at the portion B and B slide valve 22 and port A and A in the seat. Figure 9 shows the diagrammatic review of the M3A feed valve enclosed, the delivery and the supply main reserve. The main reserve air flows with the chamber K through the port K and main reserve for the air flows through the chamber K through the port P, bypass the 25 at the passage N above the piston passage N connected with the regulating valve 7 holding up at the time of the regulating spring 15 under the diaphragm 11 so the pressure passing through the bypass choke is free to flow with the passing regulation valve with the pressure to feed with the valve pipe. Consequently, as long as the regulating valve is open, the pressure above the piston 20 will be less than underneath the piston attached with the slide of the valve will remain in the open position. It will be noted that there are 2 ports through the slide valve and the slide valve seat with the feed valve of the pipe of the pressure has reduced in a considerable amount. Below the adjustment of the regulating spring of the 15, the regulating valve will be fully open with the piston 20 will move the upward to the extreme position, opening both ports into the slide valve and as they bypass the chokers restricts the flow of the main reserve of the pressure cannot build up in the chamber above the piston 20 as long as the valve 7 is fully unseated with the limits reduction feed pipe pressure has been made. Regulating valve will not be fully open. Air flowing through the bypass choke will result in lower differential action on piston 20 which will be moved upward only as far enough to port B onto the slide valve to register with the port in the seat. Alright, closing. When the feed pipe of the pressure of the diaphragm limit connected through port O becomes greater with the spring pressure acting upon under the diaphragm will move under the downward, permitting the spring 9 to seat the regulating valve 7. The main reserve airflow pressure of the bypass choke valve of the chamber of the N M above the piston 20 will quickly equalize the pressure underneath the springs. The 28 and 31 will force the end piston slide valve downward to close this position. The figure 9, thus cutting off the flow of the main reserve air to feed the valve pipe through the slide valve. The parts will remain in the position unfed feed valve. The pipe pressure above the diaphragm 11 becomes the tension regulating spring 15 when the diaphragm will move upward, unseating the regulating valve and connecting the top of the piston. 20 to feed valve with the pressure. The piston and slide valve then will be moved upward in position by reason of higher main reserve pressure under the pressure and part pistons as compared to the lower feed valve pipe pressure above in chamber M. Venture tube action. The function of the venture tube is sustained by the delivery flow of the main reserve air to the feed pipe, valve pipe at the point of the pressure to which the feed valve is adjusted. Its operation is on the same principle as the steam injector. The main reserve air flowing with the venture tube with low pressure in the feed valve develops an increased velocity as the small section of the venture tube with the corresponding decrease with the pressure at the point. The passage O leads with the venture type at the small section or throat, which causes the pressure to reduce the diameter jammer below the feed valve of the pipe. Pressure permits the regulating spring 15 to open and the regulating valve of the 7 more valve fully, this allowing the greater the flow of the airflow with consequently greater reduction of the pressure of the face of the supply piston. 20. As the feed valve pressure approaches the pressure for which of the feed valve is adjusted, the velocity of the flow for the venture tube diminishes, therefore affecting the reducing of the pressure of the diaphragm chambers, producing the proportional less than the permitting the accumulation of the pressure diaphragm chamber, which tends to close the regulating valve at the true setting. Adjusting. The M3 adjusting the turn up of the backing off the regulating nut. The M3 has 2 adjustable stops, 18 encirclement spring boxes slightly split through lugs and closed with the machine screw. The setting of the valve with the valve at the lower brake pipe setting, loosen the main screw, move the lower step of the 18 against the stop pin, which is part of the regulating nut, tighten the machine screw. Then set the valve at the high pressure with the upper stop of the 18 to hit the stop of the pin in the same manner. Therefore, after the turning the regulating nut until the pin hits at either stop, the feed valve is regulated with a high or low pressure. The M3 reducing valve should be set at 45 pounds pressure. Independent brake valve single system and the M3A feed valve adjusting stop should be placed at to give 110 pounds high, 90 pounds depending upon the class of service and local condition, or 70 pounds low brake pressure. Alright, figure 10 shows the K14 brake valve by the bypass equalizing piston top solenoid section valve. Brake valves. The automatic independent brake valves are combined with one structure mounted on the brake bracket with all the pipes. The connection are made with the brake of the valve portion to be removed with the bracket with the braking of the any pipe of the joints, handling with the automatic brake valve with the removable lap position, handling of the independent brake valve with the burning position. Pipe connection to the brake portion are provided with this valve, the 3/4 inch feed valve pipe, 3/8 inch appliance cylinder pipe, and 3/8 inch distribution valve with the release pipe of the Mark IV, 1 inch brake pipe marked BP, 1 inch main reserve pipe MR, 3/8 reducing valve pipe and marked RV, and 1/4 inch sandpipe plugged. A union T in the gauge of the equalizing reservoir connections. The brake valve portion may be removed from the pipe bracket brake backing up the nuts with the 4 bolts with the 27th of which, however, the double heading of the cocking should be closed and the automatic brake valve handle placed in the release position. The main reserve cutout cock closed in order to prevent lifting of the seat for the slide valve with the other feed valve, the rotary valve with the automatic brake valve with the independent brake valve only removed by the backing off the nuts of the 3 studs of 44. Substantially the same pressure for the brake pipe with the equalizing reservoir during the changing operations are ensured by the equalizing piston. The features makes it possible to release the brake pipe brake to make the reapplication more properly with the solid type of the piston. The collapsible type of the equalizing piston performs some function earlier to the type brake valve. The interchangeable by the bypass type of the equalizing piston. Both types are described below. The bypass type of the equalizing piston consists of the piston 32 and piston stem 33 screwed together, held together with lock nut washer 38. The stems contain with a light spring 36 which centers the spring 35 that normally holds the Wabaco check valve 34 with a bedded seat formed on an inside face of the piston. The brake pipe, the pressure below the piston equalizing the reservoir pressure above the piston equals the spring hold by the bypass of 34 seated. Whenever the equalizing reservoir pressure is raised for the higher the brake pressure, as generally occurs with the release of the brakes owing to the rapid charging of a small equalizing reservoir volume compared with the brake pipe volume, the excessive pressure moves the check the valve of the seat, permitting the equalizing reservoir air to flow with the connection at the top of the piston, but as the check valve of the spring cavity, thence through the drilled holes in the valve stem and the brake pipe with the brake pressure equalizing the spring seats with the valve, thereby closing the bypass. The surface to keep the brake pipe and the equalizing reservoir pressure approximately equalized. The collapsible type of the equalizing piston consists of the piston and the hollow stem of the equalizing discharge, where the equalizing discharge slides into the hollow stem of the piston, being held with a normal relatively portion piston by the spring of the hollow stem. Whenever the equalizing reserve pressure is raised to slightly higher than the brake pipe pressure, the equalizes the pressure at the top of the equalizing compressor, and the spring force is equalizing the piston down to a position which in the bypass groove of the bushing are uncovered, thereby permitting the pressure of the equalizing reservoir and brake pressure to equalize. Figure 11 shows a collapsible type of the equalizing piston. The six pistons of automatic brake valve handling are beginning at the extreme left of release, running, holding, lap, service, and emergency. The following paragraphs of the piston are taken in order which they are most generally, rather than the regular orders mentioned above. The release position. The portion of the piston is provided with a large direct passage for the main reserve air to the brake pipe to permit the rapid flow of the air into the later, and charged with the train brake system with the quickly release, and not a release of locomotive brakes if they are applied. Alright, figure 12 shows the rotary K14 valve and the K14B rotary valve that does not compensate for the port W. You see the port through the rotary valve, port through the cavity interior rotary valve, and the port through the cavity in the rotary valve. Figure 13 shows the rotor valve seats for the K14 brake valve. If the handle was allowed to remain in the position of the brake system would charge the main reserve of the pressure to avoid, but the handle must be moved to the front running of the holding position to prevent the engine men from forgetting this. The small port of the discharge feeds of the pipe of the air with the atmospheric to release position with a sufficient noise to attract attention to the handling position. Running position. The proper position of the handling when the brakes are charged readily to use. The brakes are not operated to end to release the locomotive brakes in a position. A large direct passage is open with the feed pipe of the brake pipe so that the latter will charge the rapidly and feed valve that can easily supply the air that cannot be detaining the pressure above which the feed valve is adjusted. The equalizing reservoir charges uniformly the brake pipe with keeping the pressure of the two sides of the equalizing piston equal. The distributing valve of the release valve is connecting with the atmospheric service position, the position with the gradually reducing the brake pipe pressure to cause the service application. The gradual reduction to prevent quick action. The brake pipe discharge gradually stop with the preventing the pressure of the head end of the brake pipe being built up with the air flowing from the rear, which may cause some of the head brakes to kick off. The lap position. The position used while handling the brakes applied with the service application until it is desired to either to make further brake pipe protection or to release them. All ports are closed. The removal of the battery rotary valve seats the release the locomotive brake case in case it is desired to hold train brakes only in the position. The plug is designated as a plug B, figure 13, and the port D, the connection distributing valve release of the pipe to the atmosphere with the equalizing sliding valve, the distributing valve, and the lap of the brake of the locomotive is held to apply with the train. When the brake valve is handled with the move, the release of the position return to the lap of the graduated release equipment of the train brake system remaining applied. The locomotive brakes are released if plug B is removed. Or your release position, the position which is releasing the train brakes after the application without releasing the locomotive brakes have been described under release. The main reserve air is emitted with the brake pipe raising the pressure of the ladder, thereby causing the car to operating valves, the equalizing portion of the distributing valve to go to release position, release the train brakes, recharge the auxiliary reserves and pressure chamber in the distributing valve. When the brake pipe pressure has been increased sufficiently to cause the handle of the brake valves, you should be moved either to the running of the holding position form when it is either desired to release the locomotive brakes and later there is to still be held applied. Holding position. The position is named because the locomotive brakes are held applied while the train brakes are released. The auxiliary reserves to recharge with the failed valve with the pressure. In this case, the use of the position is not desired for the removal of the plug and the rotary valve to feed the cause of the brake valve into function. The same in holding as in run position. The plug is designated in plug A is located with the passage for port U, distributing the valve, releasing the pipe, and seeing figure 13. The emergency position. The position when used with a very quick application of the brake is required. Large direct communication is made between the brake pipe atmosphere, the direct brake passage, and suddenly heavy discharge of the brake pipe air, causing the valves and cars distributing the valve and the locomotive to move. Emergency position given. Maximum braking force, the shutoff is possible in the position locomotive brake cylinder at pressure with maintained against the leak. The main reserve air pressure, air is permitted to flow with the sandpipe in the case of the air sanders or connected to the brake valve or the emergency relay the valve where used. Plan views for the rotary valve. The rotary valve with the seat are shown in Figure 2 and 12 and 13 with the full lines denoted for the opening of the rotary valve and the rotary valve seat. Dotted lines denote the ports and cavities in the face of the rotary pump valve with the dot and dash indicate the ports of the interior, both the valve of the seat and the offset type of the independent brake valve is handled within Figure 14. The handle is designed so that the full release of the position is parallel to the cab wall at right angles to the cab with a quick application position. The handle is slightly longer than the straight handle. Figure 14 shows the relief and the rotary valve with the rotary valve seat, the K14P brake valve. Alright, Figure 15 shows the top view of the K14 brake valve offset of the independent brake valve. The position of the independent brake valve is ordered to the left of the area. The release position. The position used to release the locomotive brakes automatic brake valve handle with the running position also may be used to release the locomotive brakes after the independent application as faster to obtain the running position. The independent portion of the brake valve is provided with the returning spring automatically moves the handle to release the position, release of the running position soon as the engine man releases his hold, and the purpose being to prevent the handle from being left in a release position, thereby impossible to operate the locomotive brake with the automatic brake valve handle. As warning of the engine in case of the broken return where the spring air is reducing the valve is allowed to escape the atmosphere, release the position. Running position. In the position communication established with the distribution of the valve, the release of the pipe between the application cylinder, the distribution valve, and A of the automatic portion of the brake valve. The distributing valve can be released with the later and the noted by the handle with the automatic portion of the running position. Locomotive brakes are being operated that can be released and simply returning the independent brake valve handle to the running position. The lap position is used to hold the independent brake applied, but after the desired cylinder pressure is obtained, which time all the communications between the operating ports is closed. Slow application position. Locomotive brakes are applied slow in this position. Quick application position. The positions are given in a quick application locomotive brakes, and the same spring of the automatic returns the hold handle from the release running position. Also returns the quick application, slow application position with the engine man released when holding on to it. The action of the spring between the two later the position serves as the quick application more prominently, so that the rapid movement of the handle engine man is likely to unintentionally pass over the quick application position, thereby obtaining the heavy application of locomotive brakes when the only light one is desired. Your K14B and K14F brake valve. The number 14EL brake equipment is furnished with either the K14B or the K14F brake valve, which is optional with the equipment. They've operated with the same manner. Either the brake valve, the K14F brake valve differs from the K14B. Only the rotary valve and the seat of the independent portion shown in Figure 13 and 15, and the K14F brake valve in the Figure 15, the independent portion of the rotary valve with the seat exhaust port of G is later in the K14B. Furthermore, the K14F brake valve is additional with the port Z, and the independent rotary valve, the connection cavity of T is longer than the corresponding cavity of KT14B. And the independent release of the portion of the K14 brake with the blade 13 elongated with the cavity of the teeth of the independent rotary valve. The 6 connects the enlarged distribution valve with the release of the port of G to exhaust port K, in addition with the connection port B to port K, as in the K14 brake valve. The plate 12 to provide two passageways the venting of the air distributing with the valve application chamber. The K14F the brake valve with the C, the plate 10 with the position of the distribution valve with the release of the independent application. The independent quick application piston of the K14 brake valve to plate with the reducing valve of the air connected with the distribution valve application chamber through the port of O, the rotatory valve of the 6 and port A, port B, and the rotary valve seat of the application cylinder pipe With the K14F, the brake plate of the brake valve plate number 10, the port Z is independent of the brake valve rotary valve that connects the reducing valve with air to the port G with the flowing distributing valve with the release of the pipe of the distributing valve, the application chamber, the reducing valve that is connected to the application chamber through port O with the independent brake valve with the rotary valve, and B, the rotary valve seat with the application cylinder pipe with the two batches connected with the distribution valve with the application chamber with the K14 brake valve and quick application position. The distributing valve is the automatic brake mechanism which controls the operation of the brakes on the locomotive in accordance with the movements of the automatic and independent brake valve handles. Figure 16 shows the number 6E distributing valve actual section. The distributing valve of the pipe connection made for the end of the double chamber, the reserve left and two on the right, of the third on the left, and the upper main reserve is the supply for the main reserve. The intermediate two, the main application cylinder leading to the independent automatic brake valve, the lower distributing valve with the release pipe through the independent brake valve, the handles with the running position automatic brake valve, and two on the brake, on the lower and the brake pipe of the branch connection with the upper and the brake cylinder pipe of the brake, to all brake cylinders on the locomotive. The distribution valve consists of the two portions called the equalizing portion of the application portion and connected with the double chamber reserve. The two chambers will be called respectively with the pressure chamber with the application of the chamber, the later ordinarily connected with the application portion of the distribution valve, in such a way that enlarging the volume of the part is called the application cylinder. Figure 17 shows the diagrammatic view of the essential parts of the distribution valve and the double chamber reserve. We're going to stop on page 12.